Now we all know that the core of the operating system is called the kernel. It is the brain of the operating system. The kernel is responsible for handling the I/O request, or the memory allocation, etc., etc. So basically, whenever we need to talk to the hardware or we need to modify something, say for example, if we want to save a file or we want to read something from our hard drive, well, we have to do it through the kernel. Well, there's a problem. We cannot directly communicate with the kernel. Well, you may ask why. Because we are the mere mortals and we are not worthy of speaking the divine language of a kernel. Well, just kidding. So basically, it's because the kernel is a very low level layer and it basically uses machine language to communicate, and for us, the users, to use machine language to communicate with the kernel is obviously not very efficient. So that's why we need an interpreter that can make this communication a lot easier. Just we will use a language and then it will interpret all of the commands to the kernel. The kernel will do its task according to the instructions and then vice versa. Okay. So what is that interpreter? That's what we call a shell. Now this shell is basically sits between the user and the kernel. So whenever we need to access the kernel, we need to tell the kernel to do something, which is basically everything because it's the core of the operating system, we tell it through the shell. Well, now there's another entity called the application softwares which may need to access the operating system's kernel. Well, again, the application software will not directly have access to the kernel. It will again use the shell to communicate with the kernel. Now the application software may need to access some file from the hard drive or maybe from an external drive, or maybe it needs to allocate some memory. Then it will ask the kernel through the shell, and then the kernel will make the necessary modification and it will communicate back to the software through the shell. Alright. Now sometimes the user do not directly access with the shell, right? Because say for example we are using a software called Microsoft Word. So in the Word we are not directly accessing the shell, but we are accessing a system, an application software, and that application software is making all the changes, the file we are writing, and then saving it to the hard drive. So that way the user is communicating with the application software and the application software is then communicating with using the shell to the kernel of the operating system. A shell can be anything. For example, the Windows operating system you're familiar with, you do interact with the operating system using a user interface, right? You use a mouse to navigate around the operating system, copy a file, maybe delete a file, move around folders and your documents, your pictures, etc., etc. You do it using your mouse and the user interface. Well, in this case, the user interface is the shell. On the Linux operating system, well, the example that I have shown you earlier, the GNOME desktop environment is also known as the desktop shell, is also a shell because in that desktop environment we can use the mouse, the cursor to tell the operating system to do certain tasks. Now there are three types of interfaces that may be used in a shell. First one is the graphical user interface that I have talked earlier, and then there is something called menu driven interface. The menu driven interface is was used in very old systems. If you remember from back in 2000, 2005 on those computers, if you log into the BIOS menu, you will see something like blue and gray color scheme user interface where there is just menus and menus and menus. You just click on a menu and then it show up a lot of other options, and then another menu, you click on it. So it's called a menu driven system. And another thing is the command line interface, or the CLI. This is very important. The CLI interface is basically chatting with a bot. So it's like I am asking something to the operating system to do something to my favor by typing it with the keyboard, and then the operating system will understand my commands through the shell. The shell will interpret it and then will do all of its tasks. Well, that command line interface is still being used, and one of the examples is the terminal that we are going to be using in this lab.